Okay.
Okay, so welcome. Today we're going to be introducing the Modern Optics, the textbook, and also the Pocket Optics kit. So it's called the Pocket Optics 1, PO1. That comes accompanying the book. And the idea behind having a kit and a book together is to have the lecture and the experiment go hand in hand. So you could first experience the first principle and apply them and hands-on. So this presentation is done by David Keng, I'm David Keng, and Stephen Arnold.
That's me. So we have a textbook, Introduction to Modern Optics for scientists and students in engineering and applied science, which is unique, and in as much as never before has anyone made such a book for optics, where there was also the ability for students, as they're reading through sections and discovering optical phenomena, to actually go over at home and test these ideas by the use of what is called a pocket optics kit, which you see on the lower left-hand corner here, and also at the lower side of the image. I'll give you back to the person who actually designed the kit, David.
Yep. So this is a close-up of the kit. So what you see here is there's a laser that's being held in the cradle, and the cradle is built on the base plate. And the base plate is a custom-made PCB, a printed circuit board. And on the PCB itself, what you see is Arduino on the corner here. And the Arduino is the brain of the whole thing, and it controls the display here. So there's a photometer right here on the detector board, and the photometer reads the optical power. And also on the same detector board, you have a RGB LED and a white LED. That allows you to have various of color of different wavelengths of light sources. So over here, you could see these are the RGB, so red, blue, and green. So there's some dip switches right here. And then also white, you could turn on and off these LED. Right now, the LED is off. Right now, the laser is shining directly onto the detector, this little black square right here. And right now, the power being read, calibrated for this wavelengths of the laser, is at 3.57 milliwatt or thereabout. And over here, what you see is it's a variable gain adjustment on the power detector. So you could have 1 microwatt, 10 microwatt, 100 microwatt, and 1 milliwatt. So you could select different ranges. So you got 4 orders of magnitude of ranges, so you could detect the optical power. And the Arduino is USB-C powered. So any USB-C cable could go in there and power the whole kit. And also the laser itself, you could turn on and off the laser right here. There's another set of dip switches on the baseboard. So you could see switch position 1, 2, 3, 4. So 3 and 4 are in parallel. So either one of them will turn on and off the laser. And then the switch 1 is allows you to switch the light sensor display, or you could switch it into a USB mode. So the data, the intensity data could be read through the USB cable and onto your PC or onto your Apple laptops. So this is one of the configuration you can measure the laser power. And now imagine if you have some samples of interest. So in this case, the kit comes with a copper sulfate solution, and it comes in with one concentration, but the kit comes with 4 different cuvettes. So the student is able to dilute it down to various concentration, and then you could study the Beer's law with it. And there's, so obviously when the light shines through this blue copper sulfate solution, some of the light gets attenuated, gets absorbed, and the amount of light receiving on the detector end is going to be diminished, and therefore you see a diminished intensity. So this is one of the 10 plus experiments we have in the book. And in addition to running the samples of the copper sulfate provided, Professor Arnold has done many other experiments using similar configurations. So,
Right. So right now, as you can see, the photometry board is set for 1 milliwatt, and so you're getting 0.06 milliwatts coming through that copper sulfate solution. As the copper sulfate concentration is changed, one is able to substantiate the exponential relationship with concentration, which then gives you the possibility of determining the cross-section of a single copper 2+ ion in that solution. The particular experiment here is basically called Beer's law. The previous thing showed on the last slide, the determination of the intensity of the laser was, which is, as you can see, at 3.57 milliwatts, was the experiment in photometry. So there, as you move from chapter to chapter in the book, there are a series of different experiments, including determining the wavelength of the laser, determining the structure of the laser from the diffraction when the collimating lens is removed, determining other aspects of that laser, because there's also another diffraction grating with a different number of rulings on it. You can see the kit teaches things which are directly in the chapters in the book. And this whole thing is in a box, so that optical bench, which you see laid out there on the lower part of the figure, now has slots in it which take gratings, polarizers, scales, and cuvettes for various experiments in polarization, and as I said before, photometry, in determining refractive index from booster reflection. And you'll notice that the board itself is itself a book. I mean, at every point there are equations which refer to equations developed in the book. For instance, Beer's law, Brewster angle, the lens resolution. There's actually an experiment which enables you to use this system, in particular the lens which is on the front of the laser, to basically turn your smartphone into a microscope. And so we are, as well as the students who have taken this course, so it's been beta tested over the last 2 years by students in my modern optics course. And no one seems to have had in their student evaluations any complaint about this, except for the fact that they want more. Right now there are 9 experiments defined by the book, and there'll be more coming based on the parts that are already there. So you have to keep on keep looking at this channel, because there'll be more experiments using the same parts. And it's a wonderful, great value. I mean, typically in a laboratory at a university, any one of these experiments would cost far, far more than the entire kit costs. And this kit does 9 experiments. And so we're really happy with it. And we think it's a sea change in education and optics to be able to do hands-on and theory at the same time.
So I'll add on top of what Professor Arnold has just mentioned, right? So in the book right now, there's 9 experiments, but the kit is designed to be owned by the students, by the engineer, by the hobbyist. So you can see right here, we have polarizers, linear polarizers provided, 2 of them. So you could do photoelastic imagings, right? Which is not described in the book yet, but you could do that. And also you got different diffraction gratings right here. It's 1,000 lines per millimeter, 500 lines per millimeter. So you could potentially do some of the spectrometry experiments as well. And also you have a pipette and 4 cuvettes. So you could run different samples in there. And also there's a piece of fiber optic, multi-mode fiber optic that could be attached to the detector and also to the laser itself. So you could run other experiments that's not described in the book. You have a bow lens. You have a piece of a stainless steel ruler that goes into the slots right here. It goes into the E and the F slots that's described in the book. So if you put a diffraction grating in front of it in the G slot right here, then the diffraction of the laser will be shining onto different points on the ruler. So the student could learn about the determination of the wavelengths of the laser. And over here, we have a turntable in the middle of the baseboard. And over here, there's attachment and the binder clip. So that allows you to clip onto different samples. And then from the Brewster angle, you can measure. The laser comes in and you turn the turntable and you can measure the Brewster angle, so you could determine the refractive index of the material, and then you could use your own material. And also there is yet another polarizer that's in a circular format that has graduation around the perimeter. It's kind of hard to see, but this is the top view of it. And that goes on that cap. It's a polarization cap. So that will be capped on the front of the laser diode, of the knurling of the lens of the laser diode. That could act as an attenuator to attenuate the laser intensity coming out of it. And so the whole kit is designed to be really modular. So the experiment listed in a book is just an example of what's possible and what the course is allowed to be run within a semester, but the possibility is endless. And then we have many students coming up with experiments of their own. So say, for example, about 3 weeks ago, there was a solar eclipse somewhere in the Boston area. That's where I am. And I used this kit to measure the intensity of the solar eclipse, the different phase of the solar power or the sun's power during the solar eclipse. And that was quite fun. So you just have an optic kit in your pocket, right? This is a very similar thing to what the electrical engineer has as a breadboard. So just treat this as a breadboard for optics. Oh,
Right. So we should also point out that if you go back just for a second to the photometry experiment, and in particular to the Beer's Law experiment, that one of the students used a blood sample inside of that cuvette and managed to determine by using the laser the attenuation by blood when it was hemolyzed, when you added distilled water to it, and when it was not. And managed to write an entire master's thesis based on the experiment she did with this kit. So it can be used by students in high schools who know less about theory, and at the same time be used both at the undergraduate and the graduate level, as it is with the courses at New York University. So we're rather proud of this. Eventually, and with the same hardware that's already there, we'll be drawing signals back for the ability to measure, for example, the absorption through our fingers, and following our own pulse rate. And for that, there will be designed an oscilloscope for computers. In either case, what you see now is all that's needed for the hardware. Okay, things will be added later. So this is a little like buying a Tesla or an iPhone. Okay, there'll be updates, but the hardware will hardly change. So
if you are interested in getting one of these kit, here's a QR code on the bottom right corner. So if you use your cell phone, scan the QR code, you'll be brought to an Amazon link. You can make the purchase there. And the key, so between Professor Arnold and I, and we spent about good 4 years improving and constructing, and keep on improving this kit, and keep on updating the textbook to accommodate more and more experiments. The ultimate goal is to show the students, as they read the textbook, they should be able to feel and touch the science in front of them. And that's the key thing. So when I was a student 20 years ago, this is a kit I wish I had. So, there's traditional experiments that run by traditional schools, and they're all great, right? This kit is not a replacement for that. This kit should be used as more of a exploratory thing for the students, right? And more independent. So you don't have the peer pressure in a lab session. You don't have a fixed schedule in a traditional lab session. You're not constrained. You're not afraid to touch things because it's already set up. And if you knock the laser off, you lose your alignment. The laser is yours. The detector is yours, right? So it's all yours. It's almost in your pocket. I mean, we made it as small as we could. It's powered by USB. It's ubiquitous. Anybody has a USB device. It's a new standard for powering portable electronics these days. So we try to make this kit with a very futuristic thinking, and hopefully you'll find this kit very useful, and you'll explore the optical science with it.
let me make a final point. If you were to go out and buy, say, the traditional optics book by Hecht, you would get a book. For that same price, you get an entire laboratory that you can use at home to enrich your understanding of the learning experience when it comes to optics, as well as a textbook. Okay, so I'm amazed by the amount of value here, and I can assure you that the feedback that I'm getting is very positive. So that's all I have to say about it.
Yeah. So Professor Arnold and I will have the YouTube channel. And by the way, one thing, every single experiment that's listed in the textbook, the kit comes with a little business card right here on the top right corner. And on there, there's yet another QR code. So if you scan that QR code, you'll see a YouTube video demo on all the experiments. And we'll keep on updating the YouTube videos on more experiments. And also, if you leave a comment there, Professor Arnold and I will be reading them and commenting them back. So in some sense, you'll get a full tech support from the author of the book and also from the creator of the kit.
Well, thanks very much for listening and coming to the Pocket Optics channel here to see what this is about.
Thank you very much.
Bye-bye.
Bye-bye.